Okay, so in this video, I'm going to go over polymorphism and how it can be used and why it's useful. So let's get started. Okay, so let's say for example, I'm working on a program for a game, like a role-playing game, an RPG, and I wanted to find a class of, let's say, a mage, right? Usually mages are spellcasters in the game. So let me start with the base class. So that's going to be class mage, and for its protected attributes, we'll just define one. We'll make an integer for the mage's hit points, or HP, right? And then for the public operations, we'll need a constructor and maybe a method to cast spells, right? So to define the constructor, same name as the class, we'll pass a parameter of HP, and this can be done two ways. We want to initialize the attribute, the protected attribute, through the constructor. We can do it this way: HP. Right, so whatever argument is passed to the constructor, then that argument will be assigned to the protected attribute here, or the instance variable. It can be done that way, or you can use an initialization list, right? And then you do that through a colon, and then the name of the attribute or the instance variable, and then in parentheses you put the parameter. Right, so either one, it's the same thing. Right, so whatever's passed here, that value will be assigned to the instance variable up here. The reason it's called an initialization list is you can actually initialize more than one attribute, right? So let's say I had int MP for magic points, then I could pass two arguments, int MP, comma, then MP, and then assign whatever parameter you have here, or argument. And if you have more attributes, then you can add more commas and initialize them this way. Okay, so the next thing we need is a method to actually cast the spell, right? So we could do this as a void cast spell, and maybe you can print out something to the screen. Let's see, something like casting magic. Something like that. Okay, so usually in most RPG games there's different types of mages. Usually you have your white mage that's more defensive, and you also have your black mage, which is more offensive. And then there's other mages that are in between, like time mages, red mages. But for this example, we'll keep it simple, and we'll define a class. We'll define two other classes, one for white mage and another one for black mage. Okay, so now for the white mage, that's going to be class white mage, and it's going to be derived from the mage class. Like that. And then we'll define some public methods for the white mage. So public. First thing we need is the constructor for the white mage. So white mage. And we'll have the same two parameters that we had for the base class. So that's int HP, comma, int MP. Okay, so here we have an error. So let's hover over it, see what it is. It says no default constructor exists for mage, right? Because by default, the derived class invokes the default constructor for the base class. So this is the base class here, mage, base class. Right, so if there is no default constructor, because we defined our own, we only have one constructor that takes two arguments, then we can use the initialization list to invoke the correct constructor. Right, so then that would be mage, and we'll pass the two arguments, right? So that's HP, comma, MP. Okay, so now the error goes away. So whatever arguments are passed to these two parameters, they'll be passed to the correct constructor now, right? The constructor that takes two arguments. And that's how you do that through a list. Okay, so since a white mage is a specific type of mage, one that's defensive, the white mage needs to cast its own type of spell, right? So we need to define a new spell method. So cast spell, and then here we'll print out something like let's see, cout something like restores health using healing magic. Okay, so now that we have the white mage, we can define the black mage. So I'm just going to get this code here, I'm going to copy it. It's going to be very similar. And then I'm going to change where it says white here, I'm going to change it to black. Change the name of the constructor. And the black mage usually doesn't cast any healing magic. Instead, it usually casts some sort of offensive magic. So we'll modify the output to removes health using maybe fire magic. Okay, so now we have two different types of mages derived from the mage class. So now let's try to use them. Okay, so let's create a white mage and a black mage. So white mage, we can call it obj white for object, and the constructor will pass hit points of 50 and magic points of 20. And then we'll make a black mage, obj black, and the black mage maybe has 40 hit points and maybe a little bit more MP. Okay, so now we have two objects, one of white mage and another of black mage. Okay, so here's the polymorphic part, right? I'm going to create a pointer of type mage, right, of the base class. So I'm going to use the indirection operator. I'm going to call it mage. But instead of pointing to a mage object, now I can point to an object of white mage, because white mage is derived from the mage class, right? So white mage is a mage. So for this pointer, I'm going to pass the address not of a mage but of a white mage. So I'm going to use the address operator, the ampersand, and I'm going to say obj white. I'll call this pointer actually mage 1, and then I'm going to create another pointer and call it mage 2, and this one will point to the address of the black mage. Right, so the same type of pointer can point to either a white mage or a black mage, because the white and black mage are both derived from the mage. Okay, so let's try and cast some spells through the pointers. Okay, so I'm going to do mage 1, and then I use the member access operator, and I don't get anything, right? So I do cast spell, and I have an error. So let's take a look. Expression must have class type, right? Because this isn't a class, this is a pointer. So to fix this, we need to dereference the pointer by using the indirection operator again, right? So then it'd be done like this. Okay, so now it works, right? Because now I'm referring to the actual object, and before it was a pointer, right? So by using the asterisk again, it goes back to the object itself, right? So if I click here, now I have access to all my members. Right, but usually dereferencing the pointer, usually it's more typing. So C++ has a shorthand for this. Instead, you would do this, mage 1, and then you do the arrow, the little arrow, and then now you have access to the members through the pointer. Right, so either one of these statements is equivalent, but normally it's done through the arrow. Okay, so then let's have mage 2 cast a spell. Mage 2. Okay, so now mage 1, which is a white mage, is casting its spell. So it should cast healing magic, and the black mage, which is mage 2, should cast the offensive magic. So let's compile this, see what happens. Control F5. Alright, okay. So we have casting magic for mage 1, and we have casting magic for mage 2. So what ended up happening was, let me close this out. Rather than calling the appropriate casting spell, it ended up calling cast spell for the base class, right? Which is just plain old casting magic, right? We wanted the white mage to cast healing, we wanted the black mage to cast fire, but it didn't happen here. So how can we fix this? Okay, so to fix this, we have to go back to the base class, and the method here, we need to make it virtual. All right, so you type the virtual keyword, and then what will happen is, instead of using this method, if we make an object of white mage that's derived from the mage class, then if we want to overload the method, then we set it to virtual. So then instead of using the cast spell from the base, it'll use this cast spell instead, right? And it'll be the same thing for the black mage, right? Because we set it to virtual, so it'll invoke the most recent method instead, right? So now let's try it out. Control F5. Okay, so then now it works, right? So mage 1, the pointer to mage 1 that points to an object of white mage, casts the health spell, and then mage 2 casts the black spell, the fire magic, right? So now it works. Okay, so probably at this point you're wondering, what is the point of using a pointer, right? The reason for that is, now that we have a way of pointing to different objects that are derived from the same class, now we're able to create an array of the base class, but with different objects in the array, right? So let me show you real quick. Right, so let's say I wanted an army of mages. Okay, so let's say it's mage, and then I can call it something like mage army. So an array of mages. Right, but the array can only be of one type, right? We can only have either an array of white mages or an array of black mages, right? But with polymorphism, I can have an array of mages, and I can mix it. I can have either white or black, right? So to do that, we have to make an array of pointers, right? So we'll make this a pointer, and here I'm going to spread this out a little bit. Now I can fill my array with either white mages or black mages, right? So I can have multiple types in one array. So you need the new keyword, and then let's say I'm going to make a black mage, and then I'll give him something like this. Oh, sorry, comma. And then I'm going to create another one, white mage, 150, comma. Now I can do another one. And then maybe one more for good measure. Okay, so now I have an array of multiple objects of different types. And what I'm going to do is I'm going to use a for loop, and I'm going to have them all cast spells. I think there's 4. And then here what I'm going to do is call the mage army, use the control variable for the index, and I'm going to have them all cast spells. Okay, so let's see what happens. Let me just comment these out real quick. Alright, so control F5. And see, now all the objects in the array are casting the appropriate spells. Right, so we had a black mage, so he's casting fire. Then we had white mage casting healing, fire again, and then one more time healing. All in one line.